quick demo of this video series. Here, we are going to implement the complete master detail CRUD operations with React.js and ASP.NET Core Web API using a restaurant app. Here we have the final project. Now, let me show you how to create a new order. First of all, here we have the order number, which is automatically created by the system. Now, select the customer. Now, from this table here, we can search and add food items into the order. So here we have the first food item. Let's double the quantity here, and then let's add drinks, same quantity. Now the total amount for the selected food item is computed and displayed within this grand total text box here. Now select the payment method from this drop down. Now submit the form. That's it, we have created a new order. Now if you click on this orders button here, it will open up a pop-up dialog while listing all of the existing orders. To update an existing order, you can select the order from this table, and then corresponding order details will be populated inside the form here. You can delete existing food item. You can add additional food items. After making required changes, the order costs around $9. Now let's submit the form. You could see the same updated order here. Now finally, with this trash icon, you can delete an order. Now confirm the operation. That's it. In this video and the next video, we will build this complete project from scratch. We will be discussing following points. How to design the database in Entity Framework Core for master detail tables with required foreign keys. Creating an API controller with web methods to implement all the CRUD operations. How to design master detail form with validation and a pop-up dialog to list existing orders. How to consume the API web methods from React.js application, and much more. So I strongly recommend this whole tutorial. And this video is sponsored by Kite, the AI-powered coding assistant, which is a free plugin that uses advanced machine learning for suggesting code completions. Currently, it supports many programming languages including Python, Java, JavaScript. You could easily integrate Kite with text editors like Visual Studio Code, Atom, PyCharm, Sublime, etc. It has a few cool promising features for faster coding. The key feature of this plugin is ranked completion. Suggestions are sorted or ranked by the relevance of the context rather than popularity or the alphabetic order. Completion from Kite are longer and relevant so that you could easily write full lines of code with less keystrokes, thanks to their machine learning algorithm. And last but not the least, if you are coding in Python, the Copilot feature offers documentation lookup right within the editor, so you could avoid frequent Google search outside the editor. We developers always come up with faster solutions for others. Why don't we try plugin like Kite to simplify our job? So I definitely think you should download this and give it a try from the link given below in video description. Hi all, welcome to CodAffection. In this video and the next video, we will discuss the complete master detail CRUD operations with React.js and ASP.NET Core Web API. Before getting into this topic, I would like to thank for your PayPal donations for my previous works. In order to make more helpful and quality tutorials like this, you can also support me through PayPal donation. I have given the link in video description and inside the first comment of this video. Along with that, I have given some links for beginners to advanced premium courses for languages or frameworks like React.js, JavaScript, ASP.NET Core, etc. Without further ado, let's get started with this topic. First of all, I will be creating the web API in ASP.NET Core, and then after that, we will build the front end in React.js. So here is my Visual Studio 2019. Now let's create the web API in ASP.NET Core. First of all, we have to create a project and then select ASP.NET Core Web Application. Click on Next. In order to implement the topic of discussion, which is the implementation of master detail CRUD operations, we are going to create a restaurant app. So I will name this project as Restaurant API. Then select the location where you want to save this project. Click on Create. From this new window here, select ASP.NET Core Web API and make sure from these top two drop downs here, you have selected .NET Core and the latest version of ASP.NET Core. Then I will uncheck this option for HTTPS, which is not required for development environment, and make sure to enable this option for Open API support, which is really helpful to test the API once it is created without the help of an external application like Postman. Okay, we will discuss that once we create the API. So here is the brand new ASP.NET Core Web API. Now let's create the DB model, and then through migration we can create the actual physical DB. For that, first of all, we have to install corresponding NuGet packages. So right click on this project here, then click on Manage NuGet Packages. From this Browse tab, search for Entity Framework Core. Now let's install this core package here, Entity Framework Core. Click on Install. Now let's install this package here, Entity Framework Core Tools. Since we are using Microsoft SQL Server, we have to install this package also, Entity Framework Core SQL Server. So finally here we have installed 3 NuGet packages for Entity Framework Core. Now back to the project. Now let's define DB model classes for various entities. For that, first of all, we have to create a new folder here. I will name it as Models. To demonstrate the master detail CRUD operations, we are creating another page inside this restaurant app. For that, we have to create these 4 tables here. First of all, we have customers, and then we have food items table. Inside that, we will insert food items served in the restaurant. And then here we have 2 tables related to order. Here we have the master table, order masters. Inside that we will have summary of the order. And here we have the final table, order details. Inside that we will have the food items selected in the order. So there will be a row for each food item selected in the order. Now let's look how to create DB model entities for these tables here. So back to the project. First of all, let's create the model class for customer. So right click on this folder here, then add class. I will name it as customer. From this DB diagram, you could clearly say that I have only included the necessary columns for explaining the topic of this video. Obviously, in a practical project, there will be more columns in these entities here. To keep this discussion short and simple, we are only adding required columns here. So first of all, we have the primary key, customer ID, and then we have the customer name. With data annotation, I will set this property as the primary key, so we have to use this attribute key. Now let's import or use the corresponding namespace. For that, you can use this shortcut. Hold Control, then press period or dot simple. Now select this using statement here. Now here is the problem. After migration, string properties will be converted into nvarchar max in SQL Server, which is more than what we need. In order to avoid that, we can explicitly set the data type with this column attribute here. Let's add the corresponding using statement. Hold Control, then press period or dot simple. Inside that we can pass this type name is equal to nvarchar 100. So that's all about customer table here. Now let's create food items model. First of all, we have the primary key. I will add the corresponding key attribute here. Then we have the column to save the name of the food item. And then we have one more column for the price. So which is of the type decimal. So once we convert this into the physical table column, it will have decimal 18.2. So we can have 2 decimal point price. Now let's set the data type here. nvarchar 100. Now let's create these 2 tables for order. After all, we can establish the foreign key between them. So first of all, I will create the master table, order master. First of all, we have the primary key. So let's add the corresponding attribute here. For these order tables, we are expecting a lot of transaction. So instead of going for this integer data type here, we can go for the long data type. And here we have the corresponding column, order master ID. And then we have order number, which is of the type string, order number. Its logic will be different to different client. It may include branch code, company code, date, etc. In this application, for simplicity, I will be providing a random number. With this unique number, employees at the restaurant can uniquely identify an order. And then here we have the property for customer ID. Inside this column, we will be saving the customer ID. Assuming that the customer is already saved into this customer table here. And then after that, we have the payment method. In short, I will name it as P method. And then we have the grand total, which is of the type decimal, so abbreviated as G total. Now let me specify the column data type for string properties here. Now let's create the final table, order details. Order detail. You might have already noticed I'm using the singular noun for this model definition here. We'll be using the plural version for the actual physical DB. Click on add. First of all, we have the primary key. And then we have the master ID. So I will just copy that from this master model here. Now we need a column for the selected food item, so which is food item ID. So here it is. And then we have the price of the item, so food item price. You may ask, the price of the food item is already there inside this food items table. Why do we want to save that inside this details table? Actually, the price of the food items may vary time to time, so we can't depend on the price inside this food item table here. We have to separately save that inside this order details table. And finally, here we have the quantity column. So far, we have created entity framework or model classes for the DB here. Now, you might have this doubt regarding the model class name and that of these tables name inside this diagram here. The name of these tables is determined from DB context class. Before creating DB context class, let's look how to establish these foreign keys here. In entity framework core, there are two ways to create foreign key constraints. Either you could use navigational property, or you can create the constraint with entity framework API methods. In this project, we will be using navigational property. First of all, let's create this foreign key between these tables, customers and order masters, with the column customer ID. For that, inside this order masters table, we can add a new property like this, which is of the type customer model class. So customer, and I will name this property customer itself. Unlike other properties inside this class, this property is of the type another class or another model. So the entity framework core can easily identify this property is a navigational property, so there won't be a corresponding column to this property like other properties inside this model. This navigational property will establish a foreign key constraint with these tables here, customers and order masters. And this foreign key will be created for these columns, customer ID from both of these tables here. Apart from creating a foreign key between these model classes here, this navigational property customer can be used to fetch a particular customer for a given order master. We can discuss that later. Now let's create rest of these foreign keys here. First of all, let's create this foreign key between these tables, food items and order details here. So let's open order details and let's add a navigational property here. We can define this navigational property anywhere inside this model class here. I'm defining this navigational property along with the corresponding ID property so that we can easily identify there is a foreign key between them. This property is of the type food item, and I will name this property with the same name, food item. So this will create a foreign key between these tables with this column food item ID from these tables here. And here we have the final foreign key between order masters and with its details table. For that, inside this details model here, I will add another navigational property, order master, with the same name, order master. I hope you already know the basics of foreign key. Since we have this foreign key between these tables here, when we insert a new record into this order masters table, the corresponding customer ID inside that row must be there inside this customers table here. So the table with the foreign key constraint will be called as dependent table or child table. And the other table, which has the principal key customer ID, will be called as parent table. And remember that this foreign key between these customer ID is created with a navigational property inside this model class here. And these columns customer ID from both of these tables is selected with a predefined convention, as you can see inside this MSDN documentation here. I have given the link in video description. You could see this section under this subheading conventions. So for the first foreign key here between customer and order masters is created with this convention here, navigational property name, which is customer, and then followed by ID. So the customer ID property is used for the foreign key from both of these model classes here. So that's all about foreign keys in Entity Framework. I explained everything in depth regarding foreign key because some of you may have some difficulties in understanding foreign key in Entity Framework like I had when I was a beginner in Entity Framework. So that's all about foreign key. Now let's move on. Now let's do the migration, which is the process of creating the actual physical DB using these model classes that we have created. For that, we have to define DB context class here. So let's add a new class, restaurant DB context. We have to inherit this class from Entity Framework class DB context. Let's add the corresponding namespace with the shortcut. Now, constructor is a must thing for these DB context classes. So I will use this snippet CTOR, then hit tab. So here we have the constructor for this class. Now let's add the corresponding constructor parameter here. DB context options of the type restaurant DB context as options. And we have to pass the same parameter to the base class, which is here DB context. So we can do this base, then pass the same. Now this DB context class decides what should be created in actual physical DB through migration. That means in order to create tables corresponding to these model classes here, we have to have a corresponding property inside this DB context here. Then only corresponding table will be created through migration. So we will create a property of the type DB set for all of the model classes. So first of all, we have customer. Now we'll name this property as customers. And the name of the corresponding table will be same as that of this DB set property here. And that's how this table is named as customers. Now let's add DB set properties for rest of the model classes. So in total, there will be 4 tables corresponding to these DB sets here. Now back to this constructor parameter here, DB context options. This parameter requires 2 informations. The type of DB provider that we are going to use, whether it is SQL Server, MySQL, PostgreSQL, etc. Along with that, we have to pass the corresponding DB connection string. As you know, the value of a constructor parameter will be passed when an instance of corresponding class is created. We will be creating an instance of DB context class through dependency injection. Don't freak out if you don't know how dependency injection work in ASP.NET Core. We will explain that in a bit. For now, let's do the dependency injection inside this startup class here. We'll do that inside this function configure services. First of all, from this iServices collection property services, we have to call the function add DB context. For this context class, restaurant DB context. Let's add the corresponding namespace. And now inside this function called here, we can pass the value for this constructor parameter here, options. For that, let me close this Solution Explorer here. And we will pass the values with this arrow function here, options. From that, we can call this function use SQL Server. Let's add the corresponding namespace. Into this function, we have to pass the connection string. So by calling this function use SQL Server, we are saying we are going to use SQL Server as a DB provider. Now to pass the DB connection string inside this function, I will save that inside this app settings.json here. So let's add a new object for connection string here. As always, I will name this connection as dev connection. Now let me paste the connection string here. So here we have the SQL Server instance installed on my system, and here we have to set the database name. I will set it as restaurant DB. Trusted connection is set as true since we are using local authentication, and we have set this property multiple active result sets as true for executing multiple query batches simultaneously. Now let's pass this connection string inside this function called use SQL Server here. We can access this DB connection string through this property configuration of the type iConfiguration. So we just need to do this configuration. From that, let's call this function get connection string. And into this function, we have to pass the name of the connection string, which is dev connection. Now we can do the migration. Before that, I want to make some correction. To make a foreign key between these master and details table here, we have added navigation property inside this order details model. Instead of that, it would be a better idea to add the navigation property inside this masters table here. As I mentioned before, when we create foreign keys through navigation property, we can use the same navigation property to fetch the corresponding data. What I meant by that, we have created this navigation property inside this order detail here through this navigation property order master. So when we fetch a specific order detail record with a given ID, we can easily fetch corresponding order master record into this navigation property using this order master's ID here. We will discuss that in a bit. But it would be helpful to create a navigational property inside this masters table instead of this details table here. Because in this context of master or details table, most of the time we will be accessing master's record. Along with that, with the given master's ID here, we can access corresponding order details through navigation property. So it is better to do the reverse navigation. So I will just remove this navigational property from here, and then I will add a new navigational property here like this, which is of the type list. I will explain everything in a bit. Order detail, and I will name this property as order details. Independent of where you add the navigation property, the foreign key between these tables will be created. At the same time, with this navigational property of the tab list, we can access all of the order details record for a given master's ID. That will be more helpful than creating a navigational property inside this order details table here. So when we fetch a given order master record, it is easy to fetch corresponding its list of details record through this navigational property here. I will explain how we can do that once we create the corresponding controller. For now, that's enough. Let me save all of these modifications here. We are going for the migration. Before that, build this project to make sure there is no error. Right click on this project, then build, Once you build this project successfully, open Package Manager console. In my IDE, it's already opened in this bottom navigation here. Make sure that from this second drop down here, the appropriate project with the DB model is selected. If you can't see Package Manager console here, open Solution Explorer, then select the project, then go to Tools, and you get Package Manager, then Package Manager console. Now, to do the migration, first of all, we have to execute this command, add-migration. The name of the migration, I will name it as initial create. Hit enter. As a result of the command execution, here we have a new folder migrations with corresponding C# files. This add migration command will not create a physical DB. For that, we have to execute the second command, update database. In my system, I can see this error, a network related or instance specific error occurred. This error is most commonly seen when we work with the SQL Server databases, and it indicates there is a difficulty in connecting with the SQL Server instance that we have specified within this DB connection string here, local SQL Server Express. Along with this error, you could see some warning messages regarding specifying type of this decimal. By default, SQL Server decimal will allocate 80 numbers with 2 decimal precision. We can have 2 numbers after decimal point. The default SQL Server data type is fine, so ignore that warning message here. Now let's solve this connection problem here. So first of all, we have to check whether we are running this SQL Server instance SQL Express in my system. To check whether we are running this SQL Server instance or not, you could do this. Open your start menu, then search for run, click on it, then execute this command services.msc. Click on OK. It will open a window listing all of the services installed on my machine. Now let's search for SQL Server. So here we have the service corresponding to SQL Server, and here we have the instance name. You could see the same inside this connection string also. Currently, this service or instance is not running. Otherwise, you could see running along with this instance here. So let's start that service here. Now let me open my management studio. Let's try to connect with the SQL Server instance that we have specified in our connection string. Connect. So here we have successfully connected to the SQL Server instance. So when you see an error like this, make sure the instance or the service is already running. If you are not using local authentication, you must be passing both username and password. In that case, make sure you have provided correct credentials. Otherwise, you will see the same error like I had here. Now, hopefully there is no other error. Let's execute the same update database command again. Hopefully we have done everything successfully. Let's check whether we have created the database or not. Let's refresh this databases node here. Expand the database node. So here we have the new restaurant DB. Let's expand this. Expand tables. Boom. So here we have the tables corresponding to the model that we have in our project. Let's check the design here. As you can see, all of these tables are created with respect to the model classes that we have defined here. Now let's check whether these 3 foreign keys are created or not. In order to see this foreign key here, expand order masters, then expand keys here. Boom. So here we have the foreign key between these tables, customers and order masters. To see in great detail, right click on it. Then click on modify. And I want to show you one more thing here. Expand this insert and update specification. And inside this delete rule, you could see cascade. That means in this foreign key relation here, this customers table is the parent table and this is the dependent table. When we delete a customer, with a given ID, corresponding order masters with the ID will also be deleted. We don't have to manually delete that after deleting corresponding customer from this table. It will be automatically done by the SQL Server engine. That's what meant by this delete rule cascade. Now in this same window, you could see one more foreign key, which is the foreign key for the same table, order masters, with this details table here. Okay. Now there is one more foreign key between order details table and food items. You could see the same inside these keys node here. So here it is. So this is the foreign key with masters table here, and this is the foreign key with food items table here. All of these foreign keys follows cascade rule. So when we delete a master record from this table, corresponding details rows will also be deleted automatically. We can actually see that later. For now, that's enough for the DB part here. Back to this project here. Now it's time to create another controller. For that, right click on this controllers folder, add controller. From this left panel here, select API. Then select API controller with actions using entity framework. Click on add. There are two tables or model classes corresponding to order. But for this order here, we will select the master model. And for this data context, we will select the restaurant DB context here. And I will name this controller as order controller. Click on add. This time here we have another problem saying there was an error running the selected code generator. We have to install this package, web code generation design. Don't freak out or don't lose your motivation. These types of errors or bugs will be shown from time to time while developing an application, and I think resolving these types of errors or bugs makes a programmer a developer. We just need to install this package here, web code generation design. Click on OK. Cancel this window here. Now let's install the particular NuGet package. For that, right click on this project, then click on manage NuGet packages. From this browse tab here, search for code generation.design. So here we have the package. As you can see here, it's already installed by default in this project. If it is properly installed in this project, you should see the same under dependencies packages here. But I couldn't see the same here. Also, you could check the same inside the project configuration file. To open the configuration file, double click on this project here. So here we have the project file with the extension csproj. And under this item group here, you should see the dependent packages for this project. So here we have the package web configuration.design, and which is not listed under this packages here. That means this package is not installed properly. So I will just do this. Just uninstall this package and then install it again. Click on accept. Now you can see the new package shown here. Now you see, this is how we handle an error. I think these kinds of skills or knowledge is learned from experience than the official documentation of the framework or the language. In my tutorials or text articles, I gave solutions for these kinds of errors or bugs that you may come across when you do the same project on your system. Let me know the errors or difficulties that you came across while developing this application. Please write it down in comment section below. Now remember, we were not able to create the order controller. Now with this package reinstalled, hope we can do it successfully. So I'm gonna try the same steps again. Finally, here we have created the order controller with the help of scaffolding mechanism. The nice thing about creating controllers using scaffolding mechanism is that within this controller we have all the web methods for the CRUD operations. We will discuss each of the web methods in great detail in a bit. Before that, let's talk about this controller constructor and how dependency injection works. For any controller that you create in this project, there will be a constructor like this. And for those constructors, there will be a parameter of the type restaurant DB context. So the value for this constructor parameter will be passed whenever an instance of this class or the controller is created. And you should know this, usually we developers never create controllers inside an ASP.NET Core project. It will be done by ASP.NET Core framework itself when there is a request into the controller. So when we make a request into this other controller, an instance of this controller class will be created, and at that time value for this constructor parameter must be passed, and that will be passed through the dependency injection that we have defined here. So this will create an instance of restaurant DB context for every new controller created, and that context instance will be saved into this private context here, and rest of the web methods inside this controller will make use of that to interact with the DB. Hope you understood how dependency injection works in ASP.NET Core. Now let's run this application. So this is how the Swagger API interface looks like, because we have enabled OpenAPI support in the last window while creating this project. Now this interface helps us to check whether the API works properly or not. If this project works as expected, we can start creating React application. For order controller, we have these much web methods. For now, I will just insert a record with the post web method here. Then we will fetch the same with these get web methods here. The first get method will return all of the order, and this will return a specific order with a given order master ID. We will be discussing rest of the put and delete web methods after creating the React application. So first of all, let me try to insert a new order with this post web method here. Along with the base URL, we have to add this URL pattern /API/order. You could see the same here, API/ then controller name. The controller name is order here. So here we have the post web method. Now let's try it out. We have to pass a JSON object to the web method, as you can see here. And if you check the post web method here, it expects an object of order master. So here we have the order master model. So we have to pass these values here. Along with that, we have to pass a list of order details. Inside that, we will be passing the list of food selected in the order. Remember, I have shown the interface or the form for this order creation already in initial demo. So while making the post request here, we also have to pass an array like this with list of food items selected with the name order details. But in this default JSON object here, it shows navigational property like customer. We don't need that. And here food item. Okay. So to create an order, we will be passing a JSON object like this. So these are the properties from order masters, and also we have an array with selected food items. I don't know whether you noticed the different casing for these properties that of these model properties here. For these model class properties, we have used Pascal casing, meaning each of the first letter will be uppercased. And that of this camel casing here, all of the words first letter will be uppercased except the first word here. So instead of this uppercased O, we have lowercased O here. You could see the same change for rest of the properties inside this JSON here. As you know, the server-side C# is uppercased, even though we are passing a different cased property here. Don't worry, ASP.NET Core will convert these camel case properties into corresponding uppercased or Pascal case properties to bind with these properties here. And don't be confused with this naming convention. When a project front end follows camel casing and the corresponding server side follows Pascal casing, these are the conventions followed in different languages. In JavaScript, we have followed camel casing for naming properties or variables, and that of this C# here, we have used Pascal casing for class property naming. So don't worry, these properties will be binded to corresponding properties in this model because of the default formatting in ASP.NET Core. when it receives a JSON object, it will convert the properties into Pascal casing, and the reverse will be happened while sending the response of the web method. The camel case properties will be converted into camel casing properties here. So be aware of these conversions, and while naming properties in React application, we must follow camel case property naming corresponding to these properties here. Otherwise, corresponding property won't be binded to corresponding model property here, and thereby that data won't be saved in our DB. So be aware of the conversion behind the scene. Now let's pass a JSON object for a proper order. We don't have to pass values for these primary key values for insert operation in any of the tables that we have created here, because the primary key columns already set the identity specification. You could check that here. For example, here we have the order master's design. With this primary key column selected, go to column properties here, then expand identity specification here. By default, identity specification is set for primary key columns. That means we don't have to pass values for these columns during inserting a new record. So it will start with 1 and increment by 1 upon new record insertion. Now after the primary key, we have order number. As I mentioned before, this unique sequence number, order number, will be different to different restaurants based on their logic of generating the sequence number. For now, I will just pass some random numbers like this. And then here we have the customer ID. For customer, there will be a drop down to select from existing customers, and corresponding customer ID will be there in this property here. So first of all, we have to insert some customers into our customer table here. In this project, we are not going to discuss how to insert records into this customers table here. It will be a simple CRUD operation. For that, I have already made a CRUD operation with React and ASP.NET Core Web API. And same goes for this table also, food items. And inside this table also, we need to have a list of food items which is served in the restaurant. So before inserting a specific customer ID or food item, we have to have the ID records in these principal tables, customers and food items. So I will insert that directly through SQL script. So just right click on this DB here, then click on new query. Then I will paste the script for inserting few records into those tables, customers and food items. I have given this DB script for inserting some sample data into these tables. You could download that from the GitHub link given below in second video description. Before executing this DB script here, make sure you have selected the restaurant DB from this drop down here. After that, click on execute. So that's it. We have some sample data in these two tables, customers and food items. Now suppose this order is made by this customer here. So I will provide the corresponding customer ID 3 here. Then after that, we have payment method. It will be either cash or card. This property grand total is computed from list of food items selected. So here we have the order details array or collection. Inside that, we can have as much as food items selected for the order. As I have mentioned here, this detail ID is the primary key, so we don't have to pass values for this column. And then we have the order master's ID. For that also, we don't have to pass value. While inserting this order with the web method here, first of all, entity framework core will insert a record in this master table here, and that master ID will be used to insert corresponding details record in this table order details. So we will ignore that for insert operation, and then after that we have food item ID. For adding food items into an order, we have a separate table in left side. So for each food item selected, there will be an object in this order details array. Now for this order, let's select some food items. We have chicken tender, so corresponding ID 2 will be there inside this property, and then quantity will be 2, and then price per single item $4.99 will be there inside this property here. Now let me add one more food item into this order. So I will just copy this object from here, then I will paste that here. So totally in this array we have 2 items, 1 item for each food. So this time I will select canned drinks, so corresponding ID will be 14. Same quantity, price per item is $1. So here we have a JSON object for an order with 2 food items selected. I know this is difficult to create a nested object, but it will help you to make a post request from our React application. And this grand total will be calculated as per the equation. For now, we'll just use the calculator. So that's it. So here we have a proper JSON object to insert a new order. Click on execute here. Thank God it went successful. As a result of the request, here we have the success response 201, meaning the record is created. And here we have the response. Let's check the same in our order tables here. First of all, here we have the master table. So summary of the order is here. Now let's check the details table. So here we have those 2 food items, and this master ID is same as that of the summary in our masters table. You could see the same in this response here. Just ignore this navigational property value for customer and food item. We can discuss that later. And what else? Yes, here we have the post web method, which is responsible for this insert operation. So first of all, the received object will be added to the corresponding DB set, and then just need to call this function save changes. Rest of these operations, both insert operation in this master and details table, will be done in the backend. And then finally, the created object is returned as a response. Now with this first get request here, we can retrieve or fetch all of the records from our master table. So click on try it out, click on execute, boom. So here we have the inserted order master record. Along with this summary, we could also fetch corresponding details record with this navigational property. I will explain that once we create our React project. So this get request will retrieve all of the existing records, and then with this get request, we can access a given specific order. For example, if we want to retrieve this specific order, we can provide one here. Click on execute. So here is the corresponding order object. Now finally, let's delete the order that we have, and it will be handled inside this web method here, delete. Okay, we will discuss each of them in great detail once we create our React project. Now we are going to delete this order which we have created with a lot of effort. With this delete web method, we can delete an order. Click on try it out, then provide the corresponding master ID here and click on execute. Just click on this execute button here. That's also done. The request went successful, and if you check those tables here, the previous order is deleted. Now if you execute the select statement again within this details table, boom. Wait a minute, what happened? I already told you that because of this foreign key here, there is a rule, cascade rule, that I have shown with the designer window. Here a master record is deleted. Corresponding master ID records within this details row will also be deleted. That's a common logic. We don't have to do that separately. The entity framework code will do that for us. So that's all about testing this web API with Swagger API here. And we have one more web method, put web method, to be tested, and we will do that after creating the React project. Now, as you can tell, we are able to implement these tested CRUD operations without any changes in these web methods here. While developing our React application, we will be updating these web methods as per our requirement. So that's all for this first part. In next video, with the same confidence and interest, we'll build the front end in React.js application. If you found this video helpful, please thumbs up this video, and for more awesome videos like this, please subscribe to this channel CodAffection. And also please share this video with your friends and colleagues so that they can also benefit from this. See you in next part.